Hey Math 3, so today I want to introduce you to inverse functions. This is just to give you notes to get you set up for class. We will talk about the key information together and we will do more examples together when we meet for class. So an inverse function is a function that undoes another function. And I printed this just because it was a little hard for me to do the fill in online. Remember, you are welcome to take your notes by hand. If at all you need to pause it and then come back, you can pause and rewind. So an inverse function undoes another function. So let's say we have a function that when you put in 2, the output is 3. The inverse function, which we'll talk about as we go through, would do 3 and the output would be 2. The perspectives completely switch. This means that the x values and the y values switch. Well, remember, we call our x values the input. Like if we put in 2 into our function, say our function is x plus 1, and then our output would be what we get. So the input and the output values are going to switch. If I want to undo what plus 1, I would say what minus 1. So my inverse function would just undo this one added 1. So to undo it would be to subtract 1. So x values and y values switch. So the input and output switch. Remember, another term that we use for x values or input is the domain. And the domain is the opposite of the range. So with our inverse functions, our domain and our range switch. A quick review, remember x values, input, domain, all of those mean the same thing. If I talk about my y, my output, and my range alphabetically, x comes before y, I comes before o, d comes before r. All of these are the same thing. All of these are the same thing. Okay, so since I'm saying x and y switch, the point xy would become yx. Yes, it's really that easy. So we're just going to take whatever our point is, if they give it to me in point form, and we're just going to flip them. The x is going to become the y is going to become the x. So if you remember from Math 2, you would write this transformation like this. So this happens when the function is reflected. So the graph of the inverse is said to reflect over the line y equals x. So it's getting reflected over that line y equals x. So that's that line that cuts like this. Okay, so if we had a point here, 1, 2, 3, 4, and I reflected it over here, it would just become, instead of 4, 1, I would now have 1, 4. The x and y's flip. All right, hope that makes sense. If a function was showing the relationship of distance based on time, that means this would be my independent and this would be my dependent. Independent's the boss. You're independent when you pay all your bills, right? So the inverse function would switch that perspective, and now it would say that we are looking at time based on distance. Everything pretty much switches. Here's example 2. If I had a function represented by this set of points, I would simply just switch my x and y. So 3, 2, 5, 4, 7, 6, 9, 8. You following? All right, example 3. If a function had the domain of negative infinity to infinity and a range of including 4 all the way up to infinity, the inverse would just switch it. So now my domain is what my range was. So my domain of my inverse would be what the range was, and the range of the inverse would be what the domain was. Domain and range switch. Okay, algebraically, the inverse of a function, f of x, is written as f raised to the negative 1x. So it was hard for me to type, but it kind of looks like that. All right. If we need to solve these algebraically, we are going to start. First thing first is write f of x as y. So if I'm going to do this problem number 1 down here with you, the first thing I'm going to do is remember that f of x is just another way of saying y. It's my output or my function. I'm then going to swap the x and the y. X and y switch. So instead of having y equals 3x plus 4, I'm going to have x equals 3y plus 4. Solve for y. So now I'm going to solve for, here's my y. So I'm going to move the 4 over. X minus 4 equals 3y. Divide by 3. And I would have x minus 4 over 3 equals y. In other words, y equals x minus 4 all divided by 3. I might also see this as x over 3 minus 4 over 3. Either of these are okay, but if I'm writing my inverse, I'm then going to write my new y as the inverse of f of x. So I would write this answer either like this, or I could write it with each of them being divided by 3 separately. So either of these would earn you full credit. All right, let's try the next example. So write f of x as y. Step 1, check. Swap x and y. So now this is going to be x equals y squared minus 3. Solve for y. Add my 3. X plus 3 equals y squared. To undo a square, we're going to square root. And remember, squared could give you 2 things. Negative 3 squared is 9. Positive 3 squared is 9. So whenever we square root, we need to write this as plus minus x plus 3. So now I'm going to just write it with the function notation. The inverse of f of x equals plus minus square root of x plus 3. And I want to make sure that square root is over everything. All right, let me try to grab a different color because these are kind of overlapping now. So there's the answer for that one. All right, last one. Write f of x equals, or just as y. Okay, so these two are really similar and I wanted to show you them on purpose. So when I switch my x and y here, you see how here the negative 3 is part of this squaring, and over here it was outside. So when I got my y by itself here, I added 3 first. This one is different because I have to undo the squared before I can move that 3 and have it free. So I'm going to take the square root of both sides. Whenever you square root, you should write plus or minus square root of x equals, now y minus 3 comes out, and then I'm going to add 3. So plus minus square root of x plus 3. Notice this x is outside of the square root because it happened after I square rooted. And then I'm just going to write my solution in function notation. So the inverse of f of x is plus or minus square root of x plus 3. Do not get overwhelmed. We're going to do more of these, but just make sure you have some good notes to refer back to in class. See you guys in class.